The interior of a vase is modeled by rotating the region bounded by the curve y is half x squared minus 1 and the lines x is 0, y is 0 and y is 15 through 2 pi radians about the y-axis. The vase is filled with water to a height of 8 centimeters. A. Find an explicit expression for the volume of water in terms of h. So we can see that it's about the volume of revolution about the y-axis, and we know the formula. It is given in a data booklet, and the required volume is equal to pi, definite integral. Limits are on a y-axis, some y1, y2, x in terms of y squared dy. This formula is given in a data booklet, and notice that it's also the same as pi integral, same limits on y-axis, but inverse function of x squared dx. So let's consider a curve which is rotated about y-axis. It will be a part of a parabola, because half x squared minus 1 it's the usual concave parabola. Vertex is at 0, negative 1, and it's also y-intercept. And you can see that it is bounded by the lines x is 0. What is x is 0? It's a vertical line through x is 0, or just y-axis. And y is 0, it's what? It's a horizontal line through y is 0, or just x-axis, and some height h, so it's also a horizontal line, and this region is rotated to pi about the y-axis. So let's show it more clear. So it's a part of parabola from 0 to some value of h is rotated by 2 pi about the y-axis, and it is given that it is bounded by y is 0. It just indicates that there is no empty space somewhere in the middle of our shape. And we need x squared in terms of y, so we need just solve for x squared. Notice that we don't need x, just x, we need x squared. So we can see that x squared is just what? 2y plus 2. So substituting this into our integral, it becomes pi integral limits from 0 to h 2y plus 2 dy, and it becomes pi, what is integral of 2y here with respect to y, just using a formula x to the power of n dx. Integral is what? X to the power n plus 1 over n plus 1, so just 2y to the power of 2 divided by 2, so just y squared plus 2, what is integral of a constant? It's 2 times 1, or 1 is y to the power of 0, and applying the same rule, it becomes what? Y to the power 0 plus 1 divided by 1, it's just y, so integral is 2y. And you remember that if you integrate something and get a result, and if you differentiate the result, you must get an expression which is equal to the expression under the integral. You can see that if we differentiate it, we get 2y plus just 2, because y derivative is just 1. And limits 0, h, and we substitute upper limit, it's just h squared plus 2h, and minus, and substitute the lower limit, it's 0 plus 2 times 0 is just 0, so it becomes pi h squared plus 2h centimeters cubed. The next, the vase is filled with at a rate of 20 centimeters cubed per second, so it can be written as dv over dt. It's rate of change of the volume. You can see it's centimeters cubed, so it's volume. per second, it's dV over dt, and that's why centimeters cubed per second. And it's increasing, so it's plus if something is increasing, the rate of change is positive. If something is decreasing, rate of change is negative. So it's 20 or plus 20 centimeters cubed per second. And find the time taken to completely fill the vase. Completely, it means what? When h will be equal to its maximum possible value, it's 15 centimeters. So we can calculate the maximum volume, or volume when it is completely filled. It's what our formula, pi h squared, so 15 squared plus 2 times 15, and it becomes what? 255 pi centimeters cubed. And hence it's quite clear that time, it's what? Volume divided by the rate, so it's 255 pi divided by 20, and using a calculator we can see that it's what? 40.1 to say significant figures seconds. And C. Find the rate at which the height is changing when h is 10 centimeters. So we need rate of changes again. It's derivative and with respect to time. Rate of change with respect to time. How quickly something changes. So rate of change. So it's dh over dt is required when h is 10 centimeters. And as usual, we need some formula which connects all values, parameters, and definitely it's volume in terms of h. So it's our pi, and let's expand, pi h squared plus 2 pi h. And notice that it's v as function of h, and notice that if you differentiate v with respect to h, it will be just 2h, pi to h plus 2 pi. Or if it would be v in terms of t and you differentiate dv over dt, it will be also pi to t. But if for example you consider dv over dt, it's not true. If you write just pi to h, it's not true. Here h, it's a function of time, and if you want to differentiate v with respect to time, it's chain rule. It's chain rule when function is raised to some power, so it will be pi to h. It's usual rule as for x to the power 1, but you should multiply dh over dt, and plus 2 pi again, derivative of h with respect to h. It's the same as x to the power 1, derivative is 1, but multiplied by dh over dt. And actually, why should we do that? Because if we have some formula and if we differentiate its average term with respect to time, we can see that dv over dt arises, and it's given, it's our rate of change of the volume, it's just 20, and also dh over dt arises, which is required, and we can just calculate, substituting 20 for this, 10 for h, and just calculate for dh over dt. Also, you may calculate this derivative if you consider dv over dt, and if it is given some function of t, not t directly, you may rewrite it as dv over dh over dt, and dv over dh, notice that derivative is with respect to the same variable h, so it will be just as usual x to the power 1, so it will be pi to h plus 2 pi and then multiplied by dh over dt. And you can see that it's absolutely the same. It may be more useful. And also you may consider dh over dt directly, and you may do the next dh over dt and dv, or the same dh over dv over dt. And you can see that dv, it's something like it cancels. And dv over dt, it is given is directly 20, and dh over dt, notice that you may do absolutely the same as for fractions. For example, 2 over 3, it's what is 1 over 3 over 2. So you may rewrite as 1 over dv over dh and dv over dt, or dv over dv over dt and dv over dh. And dv over dt it's 20, and dv over dh it's our pi to h plus 2 pi. And notice that you get dh over dt directly. You need just substitute 10 for h. So it becomes 20. We can factor out 2 pi, and it becomes what? 10 plus 1, so it's 11. 2 pi h plus 1, 11. Yes, and you need just calculate. Or if we continue this you get 20 is equal to pi to h plus 2 pi dh over dt, and so for dh over dt, and you get dh over dt, it's 20 divided by this, and we need calculate it. It's 20 divided by, or actually 10. We can cancel 2, it's 10. It's 10 divided by pi and divided by 11, and 0.289 and centimeters per second. And it is increasing, and we get that this answer is positive. We get it directly, but you should remember that if something is increasing, rate of change is positive, something is decreasing, rate of change is negative. So it's gh over h is measured in centimeters, t in its time, so we get, or we should write centimeters per second. It's required rate of change. And that's all for this question.